Hello guys, welcome back for another video, and in this one we'll be saying how to set up your code to be able to run like many jobs with array inside by cluster with SLURM inside it. Okay, so first what we need is something that will make our life easier, is something that is called SSHFS, which is basically a protocol with SSH that allow you to mount a distance folder. So in my case, I do have like my distance folder with access to a cluster with my local PC. So I can like click on it, and this is everything that I do have in my testing cluster, where there's like mini GPUs and mini CPUs with SLURM inside it. So it's much more convenient to have like this UI that you want to work with it. You can choose to write like anything with any kind of editor, so VS Code, PyCharm, Spider, whatever you want, instead of like having to write down, like for example, like we could do it like the full tutorial could be done like just with basic like command line, like I'm already connected inside, and as you can see, there's like this path that a GPU regular SLURM array, which I just showed previously, like the folder. But you know, like doing using Beam or Nano or V, it's like kind of like troublesome at some point when you need to like work with many files, and so that will like basically like save us a lot of time. So in Windows, to be able to do this, so like just to show you that we currently are in like this is the same cluster. So uh, let's go back and do that. Let's, as you can see, that those are the same file that I showed previously. Just let me show you again. Those are basically the same file. If I click here, you should be able to see that as well. Okay. So now what we need is we need to install and configure SSHFS, and to do so, it's very simple. If you are on Windows, what you need to do is just go to this website. It's basically a GitHub for Windows for having SSHFS, and just copy this, open PowerShell, and you'll be able to install SSHS. And the other thing that you need to do is configure the path and link your distant folder with your current PC. And to do so, just look at this video. It's very well made, and we will do it now in live, just a couple of seconds. So let's go back, and what we need to do is just right click on this PC map, network drive, and you just, since I already did it, this is like full, but in your case it will be empty. Just go to Z and type like SSHFS followed by your name of your machine and the IP address, and you're basically ready to go. You tap finish, and then it'll try to connect and ask you your password. Just give your password, and you will be basically ready to go. You will then be able to have access to it. Pretty simple. If you're using like Linux, it's like much simpler. And if you're using Linux, so let me show you what you need to do. So if you're using Linux, you need to like use something that is called the same packages. So what you do is apt install sshfs, we good. Then what you do is you create a new folder where you want to make the mount, the bound, that bind between the distance and your local folder. So in some folder, let's call it like cluster. And then what you need to do is you need to type the following command: sudo sshfs, it's all, and with this option allow orders, which would basically like make sure that when you do the mount, all like everything inside your PC, the programs can have access to the mount folder that you added. So let's choose the size. So go to write the full command. Yeah, this. Yeah. And basically you like now need to type your name of the device followed by the IP address, then the path that you want mount, so it will be something inside your cluster, so it can be like home, something with like your name, typically depend like what you did set up, or like your say the person that did set up the cluster made session for each person, followed by then lastly let's reduce this, followed by this same path. So we want to bind this with this, so just copy just the thing that you just define cluster, and then you will be able to see inside cluster. When you open cluster, you'll be able to see like all the folder and file that you have inside the cluster with the UI. Okay, so that's it for the SSHFS. There is also like a VS Code, but then you are like forced to use VS Code, but inside it you can have like an option with SSH, and you can use like basically the remote. So there's like something that is called, yeah, I do not have it here, but there is an extension that allow you to like with SSH connect and have like access with the editor of what is inside your distant folder. So I think it's like called remote something. Yeah, remote this one. So just install this, and you'll be able like to view like any folder inside a remote machine using the SSH protocol. But now you are bind to VS Code. You cannot use anything else. With this approach with SSH, you can use whatever you want, and that's much like more modular, much easy to do. Okay. So now let's talk about like the code. So what is the actual how to actually run multiple instances of your code for different experiments. So typically when you're working with like GPUs or CPUs, when you're doing experiments in your research, you run experiment with different sets of arguments and parameters, and you want to get you want to take advantage of like SLURM that allow you to run this with or CPU, and it will give you as many as you want. Okay, and the structure of the code should be the following. So let's go back to before explaining like each part of the code. Maybe let's go back to the whiteboard and give you like some kind of overview of what we need. So let's delete this. Okay, so usually once you are done with your code, you have something like this. So you have like your Python code, and normally you have like something that is called main or some kind of script that is main. And once you run this, it runs the code, and most of the time, if you do not have it, you should have it. But you have like something that is called a parser, which then like give to the main function all the arguments that you will use to define your experiment. And then what you do, the command line, the Python main.y followed by like some tag associated with the parameters. It can be string, can be int, whatever we want, and those define like signature of the parser and define the different variable that will be used to run the code. And now what we want to do, we want to basically do the same. So this is what we do locally. And now with SLURM, what we want to do is we'll do the same thing. Python main.py, and inside this, what we want to add, we'll add like two specific arguments that is called, that we will call like ID SLURM and name CSV. And those will allow us to basically link the different ID array that SLURM gives us when we reuse array, and link to this to a CSV that will be representing, each row will be representing the different parameters inside the parser. So 0, 1, 2, set to n will be set of parameters. So a1 to a x, and what we will basically need to do is inside our parser function, we will need to have something like a small wrapper that will like, if the ID SLURM is equal to -1, which will be the default, this is done. So it's like the normal way of doing the parser, to basically use the default value of the parser. But else, if this ID SLURM is different than -1, it will basically grab this. So it can be 0 up to n, depending of like how you define your array. And it will load the CSV and typically look at the row that was indexed. And in this example, I did like 0, but if we want to be like more general, this will be ID SLURM. Okay, and this will represent a row that can be like converted to a dict, and then using like namespace, we can like convert back to an object that is similar to what is an arc class. Okay, so that's basically the ID. it's the same. So classical will, if this is -1, it will return the classical args. If it's different than -1, it will like go check inside the different that we gave, go to the index of id SLURM, take this, convert this to a dict. Like there is like a already built method to do this to dict, and then this dict will be recommitted to like an object that is compatible with args, argpass with namespace, and then we are ready to go. Okay, so that's the basically the idea of the code. So your code. So if we want to make sure that this is usable for anyone, your code need to have like main .var. You also need to have like parser. Okay, so for now it's pretty much everything is like normal, and we need to have like two other things, which is now we need to have like the wrapper inside the parser, and we also need something that will be able to create a CSV. So something like some script that creates the experiment. Create x.py. Okay. So we need the main, we need the parser. Inside the parser, we need to make sure that we add this wrapper, basically this logic, and we also need to make sure that we are able to create a CSV that represents the parser, and we want to make sure that we can create as many rows as we want, and with also the naive approach is like to just duplicate the parser and how many rows that you want, and then just like change randomly the elements inside it. So by hand, it's okay for like if you have like let's say you have like 7 rows, it's okay. But if you are working with like let's say 100 or thousands of rows, sorry, it's not manageable, and you want to have like inside your code create X something that will help us to define the different parameters and set of grid of parameters to launch the script. Okay, and that's basically what we will see now. Okay, so let's go back to the code now and see how does this work in like life. So now this is the example. I have made like an example for GPU and CPU, but the actual like structure and code work is basically the same. And so let me show you. So there's something called util, but it's basically like for saving the parser to a dictionary and loading this same dictionary, which contained the saving with Pico and loading the Pico which contained the dictionary. But what we have is classical parser using like the argpass library. So it's common one. Like in this example, I've used this with like some kind of deep learning based code where you want to define your different experiments and different set of variables for your experiments. So nothing like strange. And then this is where the wrapper comes. We define a function that will get the arg. As I mentioned earlier, if the arg .slurm ID. So this is something that I didn't mention now, but I should mention it now. We need to add like the slurm ID and the df name inside the initial parser. Okay, so by default, the slurm ID task, we can call it this anything that we, but the idea is to call it like ID something, ID SLURM, ID. Do not like be bothered by the name. It's just some kind of ID. By default, it's -1 if we want to run locally. So if we run this locally, if it's -1, it will take like default values. Okay. And if it's different than -1, what we want to do is you want to load a CSV. And then from this CSV, what we want to do is we want to extract from the arg SLURM array task ID. This index will be used to directly index the data frame to extract like 0, 0, 1 up to n. And this dictionary will be then converted back to an arg using namespace, and that's it. So if it's different, if it's -1, this will be directly returned. So if we work locally, there will be no change. But if we are working like in the cluster and we are launching jobs with different ID array, this will be done, and it will always say load the CSV and then index with the new and different SLURM ID task ID. Okay, and this line is used for the create experiment file. What does this line is basically like with the argpass using the var built-in method from Python, convert this to a dictionary. So this parser is then converted to a dictionary. We save this dictionary in the current root of the folder. So we have like a version of your parser, and usually you want to save this, you want to make it that you run it each time that you run this function. You want to make sure that this is run, because if you update your parser, they need to be updated, because the create experiment file will use this as let's say the template row to populate the CSV. Okay, so that's the main approach for the parser. So the parser and the wrapper, that's it. And then the create experiment is basically the idea is just loading the people that we add and creating a data frame with it. We can create a data frame with it like just by copying the different, we just duplicate the dictionary, and in a for loop we add this inside a list, and then we use a built-in data frame option of like building a data frame from a list of dictionary, and then we are set up. But we can also do something more specific, which is like to create, so we want to, like if there is no config, as I mentioned, we'll just like create a list of duplicate of the dictionary that is representing the parser. So that's it. So for the range of the sample that we want, let's say we want 10, there will be a 10 dictionary that represent the parser. And if there is a config, so let's say we have like 10 experiments, and let's say we want to change the name rate and the batch size, what we'll do basically is that we need to give like 10 values and 10 value of the batch size, and this config will be used here to change the different value of the dictionary inside the list. So we'll go over the different sample. So now inside the sample, I have this experiment, and for each parameters that I do have, which is basically my config, it is a dictionary with each key being a variable, a set of variables that are inside my parser, and the key are the variable, and the values are the different value of the variable that I want to change over. So for example, my batch size can, like, the range of value can be from like 2 to like 124 with like a small change is like 8, for example, and the range can be like up to 0, 0.1 to maybe 10 power of -4, and with like a small step of maybe 0.5. But you can configure it like yourself, and I just added like some basic example, but you need to make sure that the number of parameters list that you have is directly linked with the number of sample. So that's why I'm making sure to link the config with the number of sample. So for example, if I want to have like 10 rows, this should be a list of 10 elements, because I want to change the run rate for each experiment. So each row will be having a different run rate. Same for the batch size, the idea is, and if you want to change any other like parameters, it is the same. Okay, so now what we do is we create just copy the dictionary, and then we loop over the parameters, and then for over those parameters we want to add, like, for the number of samples, a different value that were inside the parameters. That's it. Okay, then we append this to the list of experiment, and then we use this to create the wireframe using the built-in function, which is pd.wireframe, that can create a CSV with a list of dictionary, and then we save this, and then we have like a CSV that we can use to basically from each row represent a version of all parser with a different set of value from the variables. Okay. So let's first. So now that I like explained the process, but yeah, didn't show this, but those are basically like some small script that train some neural network here with some values, and that are linked with the parser. And to load the parser, what we do is we call this function then to load the parser, because now we use like this as a wrapper to either use the local parser, the normal arg, or the arg that is used with the CSV. So this parser will be called like this, and it is called, let me look for it, should be, yeah, should be at the beginning here, and it's called like this. Same for the main CPU, I guess, should be like at the beginning, yeah. And then the main function, the bottom is just using main.arg defined with the wrapper. Same for the GPU, etc. Okay, so I made like 3 sh file that we need to run to make this. The first one that is most important is to create first to run the parser. What do we run this first is to create the dictionary, and then from the dictionary that represent the parser, we want to create experiment. We want to run create which will be able to like basically create a CSV with as many rows as we want, and that represent the parser. So let's do it now. So now we are in the currently connected inside the cluster. So, and let's, for example, I will show like two use cases. So first one is creating, let's say I want to create like 20 experiments with nothing inside it. So I will be able to create a CSV with 20 rows that are the same. So I do is called trade. This will run job. This is very simple. You have like name of the partition, the name of the jobs, number of CPU, the memory of the job. So this is way too much, but yeah, I'm being greedy, but you know, and you know the you know the vibes, and that's basically the name for the logs, error and output, and yeah, that's pretty simple. And now if we look at the logs, yeah, traitors or the next namespace is here, which is represent like the parser that we have. And if we reload the code, we should be able to see a dictionary, and so this is the people with the dictionary, and this is the CSV. As you can see, there is like 20 rows and representing same value of the parser. So for example, now we just have like 20 lines. I could like just, if I want to run like example with like resonate like 101, do if I want to change the value of the learning rate, can, and that's kind of okay, but yeah, no, it's like if you want to do this for all the rows, kind of difficult. If you have like 200 of rows, it's like almost impossible to keep track. And by the way, the extension that I use for this CSV is called like Rainbow CSV, and it's very like it's life-saving. Yeah, this one when you work with CSV inside like that. So I really recommend like using it when you work with CSV inside like VS Code. And if you wanna, like for example, you're a bit lazy, and if you wanna run like and change multiple value inside your the CSV, what you do is you basically like, for example, like just over like a value, click on it, Control F2, you will be able to select all the value. So now you can go and change, for example, all the value that are for item dimension. So yeah, it would be like quite nice. And for example, I can also change to item W, for example, and so forth, so on. Okay, so you select the value, Control F2 to select every value that two are the same, and then you can change. Okay. So now it's the basic thing. It's like working like fine. For example, if you have like 5 rows, let's say 6, it's okay to change like things by hand. You can change the value of the name rate and some parameters by hand, and you can keep track. That's okay. But if you have like multiples rows, it's kind of like impossible. So what do we do in this case? We just like go to the script, and we want to make sure that we add this config and change it the right way. Okay, so let's say I have like 100. The value would not make sense, but yeah, just to give you like an example. So let's just delete this and also delete the CSV to make sure that. So run another instance of the pipeline to create both the dictionary that represents parser inside the pickle and the pipeline to create the CSV from the same path. If we go to logs, be able to see the job completed, it's quite nice. If we reload, we'll be able to see. Okay, so as you can see, now we have like much more much more rows. Seems that, yeah, I should have commented this. It's strange, the parameter did not change. So let's like just run without deleting things. So now it should like take this config and place those values inside the rows with the rule that we defined. The rule do not make that much sense, but you get the idea. So let's see if the job finished. Okay, no error, great. So should be changed. Yeah, as you can see, you'd like to have like many GPUs to be able to run patches like this, but you know, you can dream, you know. And also the value of the learning rate do not make that much sense. Usually it's like going down, not going up, but you get the idea. As you can see, those value change with the rows. Okay, so that's it for making the experiment with the CSV. And now we did the most difficult part. Then what we need to do is basically have those two scripts defined, and those two scripts are quite easy to do. First, you need to make sure that you add like the S-batch array. So to make sure that there is array in your job, just type like this array equal 0 to n with percentages n, m, and this means that all the jobs will be launched by pack of n jobs. So for example, if I type like let's say 20 and 5, so for like, so let's make it like 20 jobs. So 0 to 19, so it will run jobs in pack of 5. So it will run 0, 1, 2, 3, 4. Once those 5 jobs are finished, it will then run. It will always try to keep run 5 jobs for your station. So if jobs 4 is finished, it will run job 5. If like job 0 to 2 finished, it will run like 6, 7, 8 to keep up. So each time in your active session, you will have like 5 jobs running until those finish. Okay. And so that's for CPU. Basically, that's the common like structure. What you need to do is basically to if you are using most of the time in SLURM, the best practice to use Singularity or Obtainer. I made a video about this. I would like to create Singularity image based on Python environment. Mainly use like Anaconda, and it's pretty straightforward. It's work like 100% of the time. and it's pretty easy to set up. So any Python local environment that you have, you can create it and have it inside the singularity image without like that much headache. So I made a video and I will link down the video inside the commentary section and description. Sorry, and I also made like a video about like some introduction to singularity if you want to like a refresher, or if you want to like dig a bit more about singularity. And then what we do is just like run singularity, run singularity, run. We first give like our image, and then we just like give the command line that we want to run, and this is the SLURM ID type that we have in parser, and this thing is a variable that is created by SLURM when we use array, and this will be since in all cases there is like 0 to 19, this value will this variable will take the value 0 to 19, and each instance will have like its own ID from 0 to 19. So that's why we can link a row inside of our CSV with an ID of the job with the SLURM array. Okay, and obviously need to link the df name, which is a CSV, and the data frame is called study x main, which is here. Okay, and the GPU is almost the same. There's like just one thing that you need to add. You need to add this to make sure that it's using GPU. This is like all your, in my case, is the partition with GPU are called like this. And you also need to make sure that you use NV to make sure that NVIDIA GPUs are compatible with Singularity. Okay, and the same, there's basically the same. And now I will be logging the jobs to make sure that everything is working correctly. We launch the job with CPU and GPU, and just like since that it's the current time is like quite late, so there is probably not that much people inside the cluster. But let's be crazy and run like up to 50 jobs with like a group of like say 10. Let's split the actual to terminal, and we will see the actual jobs being run, and we will also do the same with the GPU. Let's say we do 5 because it's like the job like takes like seconds, but you know, we don't want to be too great. And same here, just like go to let's change and make it like I8. Let's make it like even. So and let's go by let's go by 25 if we can. I don't know if we can. Sometimes they're like depending of like the administrator, they impose some limits with like the number of like array that you can use. Okay. So now what we do is let me connect. And let's watch. So that's my current jobs. So let's run first the jobs with the CPU, and let's delete those to make sure that it will be easy to read all the okay. So now let's first run like the sbatch array for CPU. Array CPU. now on the right, we should be able to see all those jobs running. And isn't that like amazing, running like that many jobs? Since the jobs are like just some like numpy multiplication with like some PCA and TC, it's like a couple of seconds, but you can imagine that if your runs like up to hours or days, if you need to run like say 100 of them, you are able to gain a lot of time in your experiment like launcher. If we go to logs, we should be able like to have like some lot of things set up. And as you can see, it's like a simple CPU demo with NumPy and side-by computation, and the value changes. So should be able to see it. Yeah, the ID was 0. ID was 1 here, and also created some like simple txt that represent the value of the experiment. And for each task, you can see that the accuracy is different. Okay. Yeah, that's nice. And just to make sure, because in this one I didn't do it, but for the GPU I will do it now. I'll just print the value of the arc, just to show that the actual value is changing. Okay, so let's go back to parser, and let's just print 25. Okay, and now what we'll do is just like do the same. Let's delete this also. Yeah, I should have updated like command line, but okay, that should do it. Yeah, so now what we do is do the same, but with the GPU. Let's close all, and let's all delete everything without causing any issues. Okay, try to delete the things. Nothing. There's some stuff like logs. Yeah, so for the time being, let's just launch the jobs. So now let's launch GPU, and in the GPU it's not like just training like some kind of like random like classifier, which is basically consists of like small linear layers, conventional layers, and the arg is used here, and the value that arg do change are like data size, in channel, image size, so forth, so on, as you can see. And we want to make sure that with the print, we actually see the different value of the arg path. So let's go. Now, yeah, as you can see, it's running, as I mentioned, 5 instances of the jobs for this current section, since we have like 5 port sentences, and each time jobs ends once it's replaced, but there is also every time there's a limit of 5, so it's really added the limit with different sentences. Okay, and also the job is quite like quite like simple and fast. So we'll be able to see the result quite quickly. So yeah, now we have like the logs. We should be able to see the namespace. So yeah, as you can see, this is the namespace, just like representing the argpath. And if I go to, so this is the ID 0 array. If I go to the third one, this should be changed. So as you can see, it's .0.01, 0.04, and you basically see that the same. So now the byte size is 64, and if I go 10, byte size will be like 2122, and the learning rate will be like 0.11. And everything is completely fine. And the ID, you get the ID now, okay? So to like sum up, what you need is basically a parser with this wrapper. Then you need like some kind of pipeline that takes the dictionary that was saved inside the wrapper and trade CSV. And then you need to have like basically the inside your parser those two arguments that are both the ID SLURM that is provided by SLURM when you use array. When you do not use array, you cannot have access to this variable. And you need to also give the PF name, which represents like a CSV with as many rows as you want, and each row represents one set of parameters, which is basically a parser with set it values. Okay, so that's it for the video. I hope you liked it. As I mentioned, I have made videos on singularity and how to like basically create an images. I will let you with those, and I also give you like the code with like make a GitHub and link everything that I showed you inside the video to the GitHub, so you will be able to rerun it yourself. And by watching the video making the singularity images, you should be able like to complete the full tutorial. So thank you guys for watching, and please put that inside the comment section, like what are you working on using like those type of arrays. So what are like the domain of you're working on, and in which type of code will you be running with this. Currently I'm running some kind of cap2 jobs in like multiple arrays for explainability, so it's quite nice to be able to run this for full data sets, like saving me weeks of work. So see you guys next time.